All right, we're back, and in this one, I'm going to show you a bit of a technique. Not a lot of information here, but we are going to take this technique and apply it to some code. We're going to be talking about dividing by 10 and modding by 10. So when working with integers, there are various techniques that can be used to obtain the individual digits without converting it to a string. For instance, dividing by 10 can be used to discard the rightmost digit of a number. Now, this is largely thanks to truncation, but if you just simply take 1,337 and divide it by 10, it's 133 and some change, but it's going to get truncated because we're talking about integer division here. And what you effectively have done is gotten rid of the rightmost digit. Additionally, modding by 10 will discard everything but the rightmost digit, right? Effectively, when you take 10 and you divide it into 1,337, it goes 133 times with a remainder of 7. And what you're getting by doing this is effectively the rightmost digit. So combining these two things, you could actually loop through an integer. Oh, I know some eyes just lit right up. We're doing a coding bat. This one's coming out of AP1. It's called has1. It says, given a positive int n, by the way, don't forget to log in if you care about that sort of thing. Given a positive integer n, return true if it contains a 1 digit. Note, use mod to get the rightmost digit and divide to discard the rightmost digit. So using mod 10 and divide 10, we can traverse this integer n. Okay, one thing to note is that we're basically going to use mod to get the rightmost digit to see what it is. We'll check it to see if it's a 1. If it is, good, we can stop right there. If it's not, we get rid of it, making our number smaller, right? We keep repeating that process, getting rid of the rightmost digit every time we check and we fail to find a 1, and eventually we're left with nothing. Eventually this number, n, is going to approach 0, and so that should tell you what your condition is going to be. We will say while n is greater than 0. Okay, what I want to do is get the rightmost digit and see if it's a 1. I can use mod to do that without having to turn this into a string. So we're going to take n, mod it by 10. This is the rightmost digit. In our example, that would be a 0. In this example, that would be a 2. And I want to ask, is that a 1? If it is, we found it. We can stop right there. I'm going to return true. If I'm still here in the method, that means that the rightmost digit is not a 1. So what I want to do is get rid of it. I'm going to say n is going to be what it currently is divided by 10. Now you should recognize that we can use a shorthand assignment operator here. We could say n divide equals 10. Don't see that very often. But that will allow us to basically get rid of the rightmost digit and then save that new value back into n, thereby getting rid of the rightmost digit. All right, we'll keep going through this. If I manage to hit 0, right, once the loop is over, that means that n has a value of 0. We've looked through everything and it's not there. I'm going to put my hands on the right keys and tell it to return false. Okay, and there's our solution, right? We're going to loop through. We're going to loop through this integer n. With each iteration, I'm going to ask, is the rightmost digit a 1? If it is, I found it and I can stop. Okay, if it's not, if I'm still here in the method, I'll get rid of the rightmost digit, thereby making n a little bit smaller. We'll check the new rightmost digit. Why don't we do a little tracing here? I'll take one of these examples, maybe something a little bit interesting. This 56156 looks a little interesting. Eventually we should get true, right? So here's my initial call, right? The value of n is 56156. I'm going to ask, is n greater than 0? Yeah, okay. Is the rightmost digit equal to 1, right? Is this 6 equal to 1? It's not, so we're going to get rid of the rightmost digit. The new value of n is going to be 5615. We're going to keep going. We'll ask, is n greater than 0? It is. Okay. Is the rightmost digit a 1? It's not. So we're going to get rid of the rightmost digit. We'll ask, is n greater than 0? It is. Is the rightmost digit a 1? It is. So we would stop there. Okay. If I had, maybe 5, 6, 5, 5, 6, another example, why don't I just copy and paste this bad boy? If I started with this number, we're going to ask, is n greater than 0? It is. Is the rightmost digit a 1? It's not. Okay, let's get rid of the rightmost digit. Right, the new value of n is 5655. We're going to ask, is n greater than 0? It is. Is the rightmost digit a 1? It's not. Okay, let's get rid of the rightmost digit. Is n greater than 0? Yes. Is the rightmost digit a 1? No. We'll get rid of the rightmost digit. Is n greater than 0? Yes. Is the rightmost digit a 1? No. We'll get rid of the rightmost digit. Is n greater than 0? Yes. Is the rightmost digit a 1? No. Okay, we'll get rid of the rightmost digit. And right here on this last iteration, effectively 0 is going to go back into n, and at which point n would be exactly 0. We would ask, is n greater than 0? No. We then come down here and hit this return false. So that's what's happening there with the mod 10 divide 10. We can use it to kind of traverse a number without turning it into a string. Now that has important implications, because as long as it's a number, you can do math on it, right? If it's once you have it as a string, not so much. So that is the practical application for it. With that in mind, we're going to do a little coding. This little thing called int processor. It's a utility class. How do I know? It's got 3 methods. All of them are underlined, indicating they are static. We'll get the length of an integer. We'll reverse an integer using a string to help us. We'll reverse an integer and never, ever, ever turn it into a string. Let's take a look at this first method and get this class started. It says write a method length that returns how many digits are in the specified int without converting it to a string. Okay, you could easily just use concatenation, turn this thing to a string, and then ask how long the string is. That's not the point. Okay, like I said, there are some reasons why you would want to leave it as an integer, because you can use math functions on it. The moment that you turn it into a string, it's no longer an integer. You can't do math stuff, okay? So this method is in int processor. It's called length. It takes in an int, it returns an int, and it is static. I'm in IntelliJ. I'm going to make a new project by going to File, New Project. We'll go Next, Next. I need to switch folders. And I'm going to create this project called Int Processor. I'm going to make sure I got a subfolder and hit Finish. I'll expand my project folder, right-click on the SRC, and make a new Java class, also called Int Processor. Okay, when we're making these classes, first thing I'm going to ask is, give me some instance variables. There are none, and because there's no instance variables, this is going to be a utility class, right? There's no instance variables, there's no need for a constructor. So we're going straight to this method, length. Okay, returns how many digits are in the specified integer. So I'm going to come in here, we'll do public static int length, takes in an integer, we'll call that x. I'm going to go ahead and Java doc this. At return the number of digits in x without converting to string. It's not super important. It's not what I would normally put there in a Java doc, but length is going to be the number of digits in x. Okay, let's think about our mod 10. Let's think about our divide 10. So we're basically going to be looking at this value. We're going to be looking at x one digit at a time. I'm going to need some type of counter variable to keep track of how many digits. I'm ready to start looping. Just like with our coding bat, eventually x is going to hit 0. So we'll say while x is greater than 0. Okay. Here, I don't necessarily care what the rightmost digit is. I just need to know, is it there? So every time an iteration occurs here, I'm going to count a digit. I'm then going to get rid of the rightmost digit. And the way we do that is with dividing by 10. I'm essentially saying x is going to be what it was divided by 10. And again, we can use a shorthand assignment operator. X divides equals 10. And that's effectively it. Every iteration of this, I'm handling the rightmost digit. Right? I'm going to consider it just by counting it, then getting rid of it. Eventually, x will be exactly 0, and we can stop. After the loop is over, I'm going to return my count. Let's try this out. I like to do that in a separate class, a driver. I'm going to plug in a main method. We're ready to test the method. And because this method is static, I don't have to make an object. The way I'm going to call it is by referring to the class. And because it's in a different class from my driver, I will go int processor dot length. Right? This is a static method. It's italicized here. That's IntelliJ trying to tell me that it's static. I didn't have to make an int processor object. We're already calling the method. The way I call it, because it's in a separate class and it is static, is I refer to the class that it is defined in. Okay, I want to know what the length of 1,337 is. Right. This is going to return an integer, so I'm going to tuck that into an SOP to actually see what the value is. I'll highlight the method call to give you some separation there. Let's right-click in free space and tell it to run. And I should get a result of 4 here, right? Perfect. I'm a little skeptical. What if I got a bunch of zeros there at the end? Should still be 4. Why don't we do it with 5 just to make sure nothing funky is going on? Okay. There is a bit of a hitch with what we got going on. What if this number is negative? Okay, what happened here? Well, I sent in a negative 10,000. We come in here, x is negative 10,000. We create our count, it's 0. We'll ask, is negative 10,000 greater than 0? So we're done, and we spit back out a 0. Okay, so you can, because x will be exactly 0 by doing this, you could actually say, while x does not equal 0. And that'll allow you to handle negative numbers. I'm going to run the exact same program with just this simple change, and you see that our negative 10,000 is correctly returning 5 digits. Okay, I'm pretty happy with that one. The only little thing that's suspect, a little sus, is if we do something like this, but I mean, Java is going to get rid of those leading zeros. If this was a string, yeah. But what I'm telling you is when this gets passed in, these zeros aren't even there. It's 1 here. Okay, let's take a look at our next method. This one's called reverse. Write a method reverse that returns the specified int in reversed order as a string. Okay, this one's a little interesting. Right, we have the negative up front and it's showing the negative here. You could put it at the other end and I would be okay with that, and that may be what we do. Let's figure this out. I probably will handle the negative towards the end. Like I just want to consider it as a positive number, and then we'll worry about the negative after the fact. We got public, static. Return type here is string. The name of the method is reverse. And it takes in an integer x. I like using x here because x to me says a specific number, right? Whereas n, which is what CodingBat used, says a number, an amount, right? N is an amount where x is a particular number. And that's what we're doing, is we're reversing a particular number. Okay, what does this say? Returns the specified int in reversed order as a string. That's what I'm going to put word for word at my return annotation here in the Java doc. Okay, return x in reverse order as a string. Okay, because we get to use a string here, I'm going to start out with an empty string. And that is to kind of hold my digits as we go, right? This process is naturally going from the backside towards the front, right? We're considering the rightmost digit anyway. And so I don't have to change anything about my natural order, the natural way that I traverse this integer x. I can just start traversing. We'll say while x does not equal 0. I don't think it matters for this one, right? I think you could do greater than. It doesn't matter. I guess if we want to do negative. While x does not equal 0, I'm going to take the rightmost digit and add it to my string. Right? I want my string to become what it was plus the rightmost digit. The way that we get the rightmost digit is by taking it and modding by 10. Okay. Hopefully you recognize that this could be just shortened. Right? We can use a shorthand assignment operator, str plus equals x mod 10. Okay, so I've considered the rightmost digit. I've added it to the string. I need to get rid of it now to make sure that x will approach 0. So we're going to do x divide equals 10 to shave off that rightmost digit. Once the loop is over, x will be 0, and I've considered every digit. So we're going to return str. Let's try this out. We'll deal with the negative in just a moment. So this method I'm about to call, it's called reverse. It's in the int processor class, and it is static. So I would refer to it as int processor dot reverse. Let's throw in a number, 1337. Okay, so this is the method call. To actually see the result, I'm going to throw that into an SOP. System.out.println or sout. Let's see what we got. Okay, that looks pretty good. I may be jinxing myself here with this 10,000. I don't know how well it's going to go. All right, I didn't test this beforehand, and I don't remember the issues that occur from previous years. But let's go. The one issue that I do want to handle is this negative number. It may just handle itself naturally. No, that ain't good. Okay, so what? What do we do? Simply put, obviously this kind of breaks. It doesn't really work if I have a negative. So I want to basically get rid of the negative before I start doing stuff. Okay, so before my loop is really where I want to check to see where the negative is at. If we're going to put the negative at the front of str, not hard to do. I could just simply see if there's a negative, go ahead and tack it on to my string, and then continue. So why don't we check for that? How do I know the number is negative? Well, if x is less than 0, it's a negative number. So what I want to do is take that negative away from x, put it into str. Okay, that's effectively a two-step process. I'm going to get rid of the negative number. I'm going to make x positive, and the way I can do that is by saying that x is going to be the absolute value of what it is. X will become the absolute value of x. Okay. So it's positive. I've detected a negative. I need to go ahead and add that to str, so I can then say str plus equals this little minus, a negative sign. And that should work, right? We come in. I've got my empty string to hold the stuff. If x is a negative number, I'm going to make it positive and go ahead and add a negative symbol to my string. The rest of my code should work just fine. I'm going to run it again with my negative, and it's going to stick it there at the front. Now, if you want the negative at the end, what could you do? A couple of different ways I would consider handling it. I've never done this. One would be just a Boolean, right? You could create a Boolean to see is it a negative number, right? We would know x is negative if it is less than 0. If I'm going to bring in this Boolean, I would maybe put my neg there and then get rid of this. Okay, so I've checked to see if it's a negative number. If it is a negative number, I go ahead and make it positive. Notice that I have not added the hyphen, but I needed to check that in advance before I edited x. After the loop is over, we'll check neg again. If we did have a negative number originally, I'm going to tack on a negative sign to the end of my string. So there's one way I would handle it. Let's try running that. This one's probably really efficient relative to the next one I'm going to show you, right? There's our negative sign at the end. The other route that you could take, keep in mind that a Boolean, it takes up 1 bit. That's it, right? So this is like super efficient. I only check this effectively 1 time. So in terms of processing, that's really low. I end up saving it into the smallest bit of data possible. So this is probably pretty efficient. Another route you could go is instead of a Boolean is a string. So I'm going to create a string called neg. I'm going to check to see, is x negative? If it is, I make it positive, but what I'm going to do is not add the negative symbol to str. I'm going to add it to neg. Okay, so keep in mind I'm in the if statement. I've determined that x is negative. We need to add to our string a negative. You could just set it equal to a negative. Okay. After the loop is over, I don't actually have to check now. There's 2 possible outcomes. Either neg has nothing in it because I had a positive number to begin with, or neg is simply a hyphen, a negative symbol, because it was negative. X was negative originally. All I have to do here after the loop is basically take my string, the one that matters, the one that has all the digits, and I just add to it neg. If x was positive originally, that's going to have no effect on my string. However, if x was negative, that's going to tack on the negative symbol at the end. This one is a little bit less efficient in terms of space because a string is just going to naturally take up more space than a Boolean, but that's it. This is another way that you could maybe accomplish this, and you might be able to think of something a little bit better. I'm going to run it just to make sure we're not crazy. In fact, I'm going to go in there and change the number to make sure we're not crazy. And there we go. Okay, let's look at our last method. This one says write a method reverse int that returns a specified int in reversed order. Easy, we just did that. As an int, okay, without converting it to a string. All right, that makes it much harder. Not using a string makes it much harder. I'm in my int processor class. Let's translate this method signature into a method header. We're going to go public static. This one returns an int. It's called reverse int. Got to call it something else, otherwise the signature would match, right? I can't call it reverse that takes in a single integer because I've already got a method with that signature, right? Okay. Let's Java doc. I'm going to say returns x in reverse order as an int. Oh boy, this one's much harder. In fact, I'm going to pull my solution over, which it ain't great. I've seen better, not going to lie. Here's what I'm going to do. I'm going to use math.pow in this in order to basically to handle it, to keep it as an integer. I'm going to create a variable called pow, And what it is effectively going to be my length minus 1. It's my highest power here, length of x minus 1. Now, what is this? This is actually the method we wrote above. Okay, and I'm saying that my starting power, PAL, we're going to end up using this in math.pal, is 1 less than the total length. I'm going to have RTN, which is what I ultimately plan on returning at the end, and we'll say while x does not equal 0. While x does not equal 0. Okay, here we go. RTN is going to be what it was plus, if I do x mod 10, that is the rightmost digit, right? I effectively want to take that rightmost digit and then using PAL, like multiply it so that it's got zeros behind it, right? So for example, if we want to reverse 1,337, I basically want to take the rightmost digit, which is a 7, multiply it so it becomes 7,000, and that way when I go to do the math, right, we're ultimately going to add 7,000 plus 300 plus 30 plus 1 in order to get the number. So I'm going to take that rightmost digit and I'm going to multiply it by math.pal of 10 to our power, right? If we use that as an example, let's use reverse int of 1,337 as an example. I'm just going to leave it here as a comment. Okay, the length of this number is 4, which means we're going to do our starting power as 3. I'm going to take this 7 and that's 7. I'm going to multiply it by effectively 1,000. How am I getting 1,000? We're going to do 10 times, or whatever, 10 to the third power in order to get 1,000. So 7 times that 1,000 to get our 7,000. Okay, I want to add that to RTN. Now, this is mad at me. If I hover it over, we'll see why. It says required int provided double. What's going on here? Well, math.pal, it always returns a double, right? It doesn't matter that this is an integer, that this is an integer. It's not overloaded. It's not special. Math.pal always returns a double. So I need this to become an integer. How do I do that? Casting. Casting, casting, casting. All right, so I want to take this result and I'm going to play with parentheses here just to match what I got. And we're going to cast it. I'm going to cast it before I add it to RTN. All right, I got parentheses to make sure that this happens. The math.pal is pretty high up in terms of precedence. All of this is going to be done. Then I cast it. Then it gets added to RTN. Okay, again, what we're doing is we're taking the rightmost digit and multiplying it by 10 to some power. In my example, the first iteration of this would take 7 and multiply it by 1,000. We would then take 3, in theory, 3, and multiply it by 100, right? So what that tells you is that PAL needs to get smaller, but also X needs to get smaller. So don't forget both of those things. Each time I do this, I'm going to get rid of the rightmost digit because I just considered it. I then need to lower my power just by 1, right? Initially, in this example, this was 3. On the next iteration, it would be 2. Eventually, X is going to reach 0, at which point I would stop. I'm going to return RTN. Okay. Let's try it out before I make any more comments. I'm going to sout on int processor dot reverse int. Let's do something a little bit different. I'm just going to throw a number in there. Looking good. As I said before, I've seen better to this. I've had students come up with better solutions. I didn't write them down. I should have, but this is what I got. This is what's in the slide. This obviously works. Let's try it with a negative number. I have no idea. I'm probably about to break it. That's good enough for me. Okay, this has been Mod 10, Divide 10. I'll see you in the next one.